And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be performing some upgrades to our Meshtastic node. A while back the box failed and I had to reseal it. Got a lot of water in there, and ever since then that node has been not receiving very well. So I think it's time for some upgrades. First things first, let's get that mast down. Right, you can see I struggle to get the lid off. That's because I sealed it with this stuff when I had the water leak issue. So see if we can't prise the lid off. I tell you what, that's stuck well, isn't it? Where's that fat screwdriver I had a minute ago when I was outside? God, we're in. Yeah, okay. Right. According to that, this is still running. Yeah, it even says that it's still running, but I do know it happens to have a pretty serious problem with its reception. So yeah, it's going to have to go, I'm afraid. Let's just disconnect the battery for now. There we go. Yeah, it drops network. It's been particularly reliable of late. So it's the end for that one. This, by the way, I didn't show this originally. This is the environmental sensor you can have. Look, we've even got a spider on board. Right, where was I when I was so rudely interrupted? Yeah, you can see this was the damage done. There is no wet in here anymore. And although I did my best to repair this Heltec, I think it's had it. So I don't think that's looking very healthy either. I do need to salvage the antenna and the battery if I can. So I put it in with a blob of silicon rubber last time. So this might not be salvageable. That's moving. Where's that big screwdriver? Yay, there we go. Lovely. Okay, so we know the battery's still good. The rest of it, I think I can junk once I can get this antenna out, which is it's going to come away all right, I think. Need to get quite a large spanner on there. Use the spanner I had outside to undo the mast. Right, where are the flats? They are there. Am I going to be lucky or am I going to be out of luck? Ah, lucky. Right, we shall come back to that. I may not be reusing this antenna actually in this project. I may be using this one in another project later on. So we can put that to one side anyway. And that is all gash. I shall recover the brackets, the clamps later on, but I'm not interested in any of that. I suppose the first thing we ought to do is flash a new Heltec. In fact, I'm not going to flash it just yet because I need to connect an antenna. So yeah, the other thing I want to put in the box, I actually want to expand the mast slightly, and I want to put in another Heltec, but just running TinyGS on the 868 megahertz band. Now for that I can't sort of tee off the antenna because TinyGS is a receive only project. So obviously if our main antenna, if our main Meshtastic node goes into transmit, it's going to transmit into the output listening to the TinyGS and will wreak havoc if not do damage. So we don't want to be doing that. So yeah, I'm going to need a bigger box. To that end, I have bought another one of these Guice enclosures, the one with the hingy out lid that I love so much. And this time I'm not going to mount the antenna to the box. I'm actually going to mount it to a sort of cross member I'm going to put on the mast. And I'll show you that a bit later on. In fact, you can hear the 3D printer whirring away in the background. It's making me some parts so we can mount all the bits and pieces on the mast. So there we go. Right, we've got plenty of room in this box, so that's really good news. I'm not quite sure which way it's going to go up yet. I think it'll go that way. So I'm going to need two TinyGS units, sorry, two Heltec units. That one is now scrap. The other one I've got is a is already in use. I don't know whether you saw the Ham Radio Kia video the other weekend, but you'll see a stack of things with voltage displays on. Well, that's all my little Raspberry Pi projects that are running. They're all connected to a distribution amplifier and are fed with a dual band collinear. So my 433 megahertz TinyGS is on a Heltec unit that's 433 megahertz just outside there, but all the other Raspberry Pis, one is the NOAA satellite receiver, there is an APRS receiver, the WeWX receiver, which is 868 megahertz, but they are all fed from the main sort of collinear antenna that's on the other mast, except for the NOAA antenna, which is actually on the shed. But they're all in that stack. I got sick and tired of having Raspberry Pis everywhere, so I 3D printed like a stacking system with fans top and bottom. And in the bottom of there is a distribution amplifier that distributes all the signals to the various Raspberry Pis and their SDR receivers. So yeah, if you want to know more about that, leave a comment below and I'll take you through it in some detail. But it's really just a set of different projects that I've sort of brought together and put in a pile in a more neat manner than having them all strewn on the shelf making a mess. So yeah, I'm trying to get tidy in here. It'll never happen, but we're making progress. Right, so first things first, I have 3D printed two new mounts out for the Heltecs. So we're going to have two in there somehow. I probably won't be installing this battery onto the Meshtastic node, and we'll come back to that in a minute. But this is going to be repurposed for something else. That was made from vape batteries. I've shown you those before, and in fact in the original Heltec base node video I think it took you through that. So yeah, anyway, right, so moving forward, what do I need? I need to retrieve the Heltec TinyGS node from over there on the shelf. Like I say, it's currently running on the 433 MHz antenna, and it's utterly useless. So yeah, I have yet to receive a packet. If you go to tinygs.com and type in search stations and G7GQA, you'll see there are 3 listed, 2 433s and a 868, and the 868 one has not got a packet to date. I don't think many satellites are supporting it, but it's another fun project, isn't it? Right, let's get started. Now, with TinyGS, I'm going to replicate the environmental sensor, put that near the bottom of the box. Right, well, I don't know whether you noticed in that scene, but I wasn't making much sense for a lot of it. I edited a lot of it out. And to that end, I got very unwell the following day. Yes, I've been out of commission. And I did continue to film, but quite frankly, some of the footage was utterly rubbish, even more rubbish than usual, perhaps I should say, because I just wasn't well. I was just mumbling and just not making much in the way of sense. Anyway, I'm back fighting fit now. So yeah, one thing I did manage to do was 3D print out this rather marvellous mast clamp. It's just a square base there with 3 slightly less than 32mm sort of grippy things there. Our mast is 32mm in diameter. This is about 30, I think. So there we are, and we could put a nut and bolt through that and then clamp this whole box to the mast. And that's bonded on there with araldite or any other epoxy you want to use, a two-part epoxy. On the inside, I had fabricated a base plate, but I wasn't happy with it, so I've actually just remade this. It's a little 3D printed part, as you can see. 2 L's there to take our SMA connectors, and just 2 of the same model as the sled that we used previously in the node, just to hold the 2 Heltecs in. So the plan is to sort of bond that into position in here, and then yeah, just slide the Heltecs into place. And I may as well do that first, might I? Might be easier. Slide the 2 modules into place, and then just glue it all in. I have, however, fitted the wiring for that, and it's going to be difficult, isn't it, for the environmental sensor. There we go. Yes. Needed to modify the model slightly and didn't for that one. Let me just modify my 3D print very slightly by losing that corner off that piece. There we go. That's because we've got some extra wiring in there, so I can supply power across both modules like that. Ground is that one. There we go. I think if I can, I am going to reinstate the battery. Don't know why I wouldn't, really. So yeah, that's going to mount in like that. Those are going to just slide through there if they will. We may have to enlarge the holes slightly by the look at that. No, that would be all right. And there you go. So we can have our 2 coaxes coming in here. I'm going to have some short coaxes because I want to space the antennas out on the mast, which we'll come to in a bit. Right. Yeah, I think the next thing to do is just to put this all together, isn't it? Right. Right, so you can sort of see how that's going to come together now. Need to work out where I can mount the battery, really. I think it's going to go up the top here. Ooh, I may struggle. Maybe down there, I don't know. Quite a bit of wiring on it, so that looks like a distinct possibility to me. I'm just going to clean up the rubber that was left from when we extracted it from the base and have a little go at remounting that. Yeah. My glue has all gone off beautifully. We have got the TinyGS receiver here and Meshtastic transceiver here. These are for the incoming DC. I have connected the battery. I've not soldered the final lead onto it because I don't want the mesh node powering up without an antenna connected. I've mounted the two SMAs there, so I need to put 2 holes in the bottom of the box, 3 holes really, 1 for power incoming and 2 for the coaxes. I'm not going to mount the antenna on the box this time. I think that was partially the reason why the last box leaked. I don't think it leaked through that, but I think it cracked it with the wind load maybe. So I've 3D printed some mast bits. The other thing I'm going to need to do is to make an antenna for TinyGS on 868. So let's have a look at that. Right, so to make our TinyGS 868 megahertz antenna, I want something that's not got a low angle of radiation, something that's quite broad. A dipole, for example, would work, although we're going to make a quarter wave ground plane, which effectively has a little bit of a gain because we're not looking at the floor, which we don't really want. We want to be aiming for to the horizon and above. There will be a patch above us where we don't get coverage, but yeah, that's just the nature of the beast. You could make an egg beater or something like that. That involves phasing harnesses and it's far too much bother for this little project. So I've had a nice walk into Cheltenham Town Centre because it was a beautiful day and visited the very wonderful Cheltenham Model Centre. Insert picture here. They do assure me that the frontage is going to get a lick of paint shortly. They're just doing some renovation works in there. But what a fabulous place. If you're in Cheltenham and you're into modelling, yeah, go and give it a visit, especially the amount of model railway stuff they have in there. I could see me getting into that. Maybe when I retire. Anyway, yeah, go and give them a shout. They're wonderful people to deal with and it really is a great place. Anyway, I visited there and I bought this. This is some copper tube. I've used this previously on the channel when we did the 433 megahertz quarter wave. So yeah, this is the same MO really. This is K&S Precision Metals. You can tell it's good. It's made in the US of A. It was £5.40 for 3 lengths of it. We should have enough in there to make our antenna. I've also got just an SMA connector, which we're going to use as the base of our antenna. So yeah, let's open the packet without cutting any flanges off. There we are, and extract a length of this. And hopefully I've picked the right sort of diameter that it'll slide over our centre pin of our connector. Here's hoping. They also do this in brass, which is just as good. But there you go, that's absolutely perfect. So, next trick is to visit the M0 UKD website and click on the calculate my ground plane antenna and it will suggest some lengths that we need to cut. In this instance we've got 82.1 millimeters for our driven element, if you like. It's going to be sticking up vertically, and it suggests for our radials of 91.9 millimeters, so it's quite a small antenna. So yeah, I am going to rely on the ground plane as being about right, and we're going to cut these to 92 to start with. Where are we? 95, 93, 92. We want to be sort of semi-accurate with that. Oh, I've moved it now. We're not going to, because we're actually looking at quite a wide bandwidth of received signal. We don't have to go mad with it. Let's mark that with a Sharpie. We'll cut that there. Now, when you're cutting this stuff, if you're not fussed about it, you can just sort of cut it with a pair of maybe wire cutters that you're not that fond of. I'm going to use a hacksaw because I want to preserve the end being round. All right, it's going to have a burr on it, but yeah, that's what I'm going to do. I need the universal vice. Where is it? It's over here. So get as accurate as you can with this. We're going to actually cut the vertical element long. We'll do that one last. We want 4 of these at 92mm. So we want the waist side of the line, which is that side there. Should have used my junior hacksaw for this, but it's gone missing. Found the blades, can't find the handle. This is quite soft stuff, this copper. Starting to snag now. We should be able to snap it. There we go. We can just snap the rest of that off, tidy it up with a file. I want a flat end again now, so I'm just going to touch it up with a file. Oh yeah, precision engineering at its finest, this is. Right, rinse and repeat until we got 4 of these. Right, so those are our 4 radials. Now, for the driven element, the website tells us it's 82.1. Now, you know what? I'm going to cut it long still. So we can always cut it shorter. And I've zeroed that, which is careless. So I'm going to make this 90mm so we can just, or there or thereabouts. And then we can tune it using the Nano VNA. So we'll try that for a start. You know, you could build one of these antennas for any 868 megahertz LoRa project if you wish. It'll work just as badly on all of them. I'm just going to put a stripe in the middle of that so I know which one is the driven element when we come to assembly. And as I'm going to be trimming this, I don't have to be that accurate with it. As long as it's too long at the start, we'll be absolutely fine. That's it, I reckon we've got enough metal in there to make probably 2 of these antennas. Probably one at 433, but yeah. Right, and the next trick is going to be to solder the driven element onto the centre of our connector. So soldering iron on, I'm going to want a drop of flux. Let's get it all aligned up in a bit of a universal vice before we go mad. I'm going to try and get it as sort of square as we can. By the way, this will be longer as well because technically we measure from the base this insulating section there. So we will also need to trim. If you look at the website calculator, it does say where you take the measurement from. Right, looking pretty square in that direction. Looking lovely and square in that direction. That works for me. Right, we shall have a splash of flux just to help matters. I've got the big soldering iron tip on because we are going to want to move a bit of heat. So I'm going in. Right, obviously that solder's got to wick up inside the tube to get a joint, so hopefully that has occurred, and yes it has. Wonderful. No it hasn't. Oh, I thought it had. Right, I think what I might do is just tin that centre connection there and have another go at that. Might be a little bit more keen now to take the solder. Line it back up again. That looks reasonable. Looks reasonable. I just want to pull it apart slightly and then it'll... Yeah, it gives the solder a direction in which to travel. That looks square there. Yeah, most acceptable. Close enough for government work. Right, let's try that joint again. Splash more flux. There we go. See if we've got it this time. Oh yeah. We certainly have. Excellent. And for the next trick, we're going to want to solder these on at a 45-degree angle to the side here. And this is how I'm going to do it. I'm going to file a notch in the end of there with this ridiculously oversized file, so we get a V in it, and then I can butt it up and just solder it, and that'll work nicely. So let's get my file in there. I think this is going to be a job for some magnification. Not happy with that. I think I need to find my other square file, which I've got a sneaking suspicion has long since vanished. Well, I've got this one which is flat, but one side has got an serrated edge, so if we just file that with this, that should be a little bit better. I think that will do us. I want to get it corner-wise on. There is the universal vise. So I want to put this sort of 45 degrees on so I can solder onto the corner. We want to go in at that sort of angle like that. That looks fairly square. Splash of flux. And we're going to want quite a bit of solder to make this joint mechanically strong. Things are not quite becoming hot enough. There we go. That looks reasonable. We now need to do the same to the other side. You know what, I might not bother filing the slot in it this time because I think that's just made things more awkward. There we go. Of course, doing this next bit, it's going to be a little bit tricky, isn't it? Do I want to solder it by hand and just get it in there and work quickly before I burn my fingers? Or do I want to come up with a better plan? I want something to stand it on, really. Yeah, let's just wing it, see how we get on. Flux the end of this tube up first and solder it up. Right, this being copper and a terrific conductor of heat, I'm going to want to move fast here. Let's get a bit more solder on there. One more to go, which is going to be trickier still. Yay! Right, and just to see how far off our legs are, we know the lengths are fairly accurate. Let's see how much it wobbles about. Yeah, that's this one, isn't it? You can sort of see. Oh, that's rather warm. I'm just going to leave that to cool for a second. I've just heard the 3D printer stop in the background, which is good news, because that's the next part of the project, which is to make a little radome for the top. Pretty reasonable. Right. Here's my little radome of 3D printed for the top. It's just a bit of tube, 3D printed with a sort of castellated top, which by my calculations, if I'm right, this should just slide into. Right at the moment the driven element is too long, it's hitting the end. So let's get this tuned up and yeah, let's make some adjustments to the length, get it resonant and matched on 868 megahertz, and we'll see where we go from there. Right, so after quite a long time of messing around trying to find out what was wrong with my VNA, turns out I had an open circuit patch lead which has now been relegated to the bin, never to be used again. I've got the thing calibrated up, and if we look at nano VNA over here, you can see we are indeed too long. Our frequency is too low. We've got a low point down here somewhere of 723 megahertz. So we want that to be 868. So let's punch that in there. And you can see at 868, yeah, didn't like that. Why didn't it like that? 868 megahertz. There we go, it's given us 867.9. Yeah, we are at 100 ohms, so that's not much use. And we're up here on the graph. So yeah, and the Smith chart, we are well into the inductive space stage of life, so we need to bring that down here, so we're going to have to shorten the antenna, which we sort of anticipated. So yeah, I'm going to start by just snipping a couple of millimeters off. Cool. I need something to steady my hand again. I'm going to use this can. There we are. Right. That is now a couple of millimeters shorter. Let's run the sweep again. And you can see we haven't moved it far, have we? Yeah, that is completed, so we haven't moved it far at all. So let's just snip another few millimeters off. Let's go for about 5 mil this time, shall we? More like 8, but I think we've got a bit to play with just yet. Sweep again. Oh, we're getting close now, look at that. So where's our resonance? Our resonance is, just select marker 1 so I don't move my 868 point. So we've now got, yeah, where are we? 788 megahertz. So you know, we're getting close. Let's lop a bit more off. Where's my can again? I'll steady my hand somehow. There we go. Run the sweep again. Now you see we're starting to move that peak down. Where's our resonance now? So we are there. We're aiming for J of 0, so minus 2.96. Well, that's not bad, is it? We're on 817. Once again, let's make another cut. Move my can out of the way, otherwise it will affect the measurements, and I'm sort of standing back a bit from it. Not for any health risk at all, but yeah, here we go. Ooh, where are we? That's a very odd looking plot. Let's just run that again. There we go, that's more like it. So yeah, we're just on the flat bottom half of this section now. So what's our return loss? Minus 16. We're getting good. I'd like to see it down here. I reckon we just need to snip a sort of millimetre off this and we'll be somewhere on the money. And even if I do over egg it and we go a bit high frequency, it is just a receiving antenna, so I'm not that worried about it. Right, let's have a look now. This is looking good there. Aren't we coming round? Yeah. I'm going to stop there. That's looking pretty good. So we have got an impedance 63 ohms minus J of 10. We'll probably need to shorten our legs a little bit. We've got a 1.3 V SWR minus 16 dBs, quality factor of 0.14. So that shows how much. But I mean, you know, we've got a good wide bandwidth here. Let's just narrow this in a bit. So let's go from 750 megahertz. Let's stop at 900. Let's run that again. Zoom in a bit. There's our 1.33. You can see we're not getting much below that. Let's just try snicking 5 mil off each leg. In fact, I tell you what I'm going to do. I'm just going to hold it in the air. See if that improves matters any. Sweep again. See what effect I sort of have on it. I'm holding the damn thing. Oh yeah, you can see the peak now is very much better. So the bench is affecting things a little bit. What frequency is that? 864. And we, if that's 864, what's 868? That marker's moved, hasn't it? Let's put 868 in there and see what it gives us. It's 869 megahertz. Wow. I don't think I'm going to worry too much about that. What have we got? 869 megahertz, 52.4 ohms. Yeah. That's pretty good. I think I'm going to stop there. Let's see if it now fits in the radome. Put my Nano VNA to one side for a moment. Or am I going to have to 3D print another radome? Oh no. So that's, whoa, that's perfect really. Lower that a little bit. There we are. So it all sits semi-happy. Now all I need to do is 3D print some sort of bracket. I'm half tempted actually to just sort of glue that in the bottom there. And I think we do need a bracket, don't we? So if I make a piece that slides in on top of that, and then off to the end of our horizontal mast assembly, I think we'll be somewhere near. Anyway, that's good news. Right, let's design something, 3D print a little base, glue it together, and move on in life. Right, well, I just thought I'd show you what else is going up the mast. This is my ADSB antenna. This is one of these sort of printed circuit board antennas, again from AliExpress. You can see the two elements there, and there's a bit of a match section there. And I have grafted on, this would have originally had a SMA connector under here. I've grafted on an ADSB 1090 megahertz antenna amplifier and filter. It's got 38 dB of gain, so I can push the signal down a relatively rubbish bit of coax. After that, this again would have had an SMA connector on there. You can just see the three wires in there that I've linked out, and I've linked them across the back as well with a piece of copper strip. That then feeds just this bias T here, so I can send power up the coax and then have it all powered just remotely. And what I've done is I've got a piece of PVC drain pipe, and the idea is the antenna is going to sit in there. I'm going to push the connectors through this hole. This is another one of my dipped 3D printed parts, so the coax is just going to come through there, sort of like that, and then this is going to go over the top and form a bit of a radome for it, and that fits on there like that. Again, this top piece here is 3D printed, just the cap, keep the wet out, and then you can notice here that that's got a box shape in it. It's showing up really well on the cameras. Let's try and catch it in the light. There you go. And that's going to take the arm that's going to go across the top of the mast. I'll just show you that. And what I've got is a lightweight piece of aluminium box of some length. It's got to be getting on for 1.5 meters long, so that can space our antennas out. Now, because on this end I intend to have the 868 receive antenna, what I'm going to do is put the other 868 antenna transmitting on the end of here to give us a bit of distance between the two, so one isn't quite shouting down the neck of the other. And then we'll put the ADSB antenna somewhere in the middle. To mount this to the mast, I've 3D printed and again dipped a couple of brackets here. You can see that's a mast bracket there. That clamps on there, and then our section fits through the middle there. I've also put a little a hole there, so I can just put a screw in there to stop it all moving about, and then that bolts together. So yeah, that's it. I'm still waiting for the final 3D printing piece to finish, and then we can get it assembled. Right, well, I've got myself a patio table workbench, which is very convenient because it has a hole in the middle for a parasol. So this is the mast as it exists. I've taken the weather station off. The first thing we want to do is fit our cross member across the top. Now north is that way. I really want this to be sort of a bit like that really. So we're going to go with that. I've got a bag of M5 nuts and bolts here, so hopefully we'll have something suitable for bodging this lot together. This may be a little more difficult than I'd at first realised, because I can't get at those top holes because this bracket is secured, so I'm going to have to slide that off, which is going to mean undoing the other two, but that's okay. Error in the design slightly. Oh. Right, well, that's the sort of kip of it there. Quite pleased with that. Next thing to do is mount the control box on. And we have terminal failure of the 3D print. That needs to be a bigger dimension. I'm going to have to go and make another. Suboptimal 3D print failure. Unfortunately these slip over the mast, and I didn't make them strong enough or fat enough. So I've 3D printed another one here, which is a little bit different dimensions, and it's got a bit more infill. So there we go. That is now ready to go up the mast, more or less. So that's good news. The only thing is now obviously I need to connect the SMA connectors to their respective antennas on the mast, and they're going to be opposite ends because I don't want the LoRa transmitter shouting down the neck of the TinyGS receiver. So I'm going to space them out as much as I can. So yeah, right. To that end, we're going to need some coax. It's only a short length, but even so at those frequencies it's quite lossy. So the coax I've chosen for this particular job is RG142. You get this from reputable suppliers. I didn't buy this from a reputable supplier. This is AliExpress's stuff, and I've used it before from the same supplier, and yeah, it's pretty much to spec. So we're going to use this. It was not expensive. Also, I've got some crimp on SMA plugs. What I'm going to do is I'm just going to fit one, put it on the mast, work out the length I need, take it off, cut it, crimp the other end on, and a bit of back to it and throw in. So yeah, I'll show you how to fit one of the plugs though. These came from AliExpress as well, and I'm manufactured by the Wuhan Hengui Tonda Construction Engineering Company Limited. Wuhan. Weren't they slightly responsible for something else? There's one for the conspiracy theorists. Anyway, right. So they come in three parts. We've got a crimp sleeve, which is that piece there. We've got a pin, and we've got the plug body itself. So I'm just going to need those three bits for now. Wish I hadn't picked them all out, but hey, let's just put this all away again. Don't you go rolling off. Right, so first things first, we're going to have to work out how to fit the plug, because clearly it's not an official Amphenol or whatever plug. It's apparently designed for RG142, but we are about to find out. So first off, we just want to remove the jacket from our coax, hopefully leaving the braid intact. Here we go, that's good stuff. Now I'm thinking the way this works is this pushes up behind the braid, pull the braid back over the jacket, that pushes up over the jacket, we solder the pin on, that all slides in there and crimps together. I could be wrong, I could be about to be embarrassed. We will find out in moments few. Oh, super tight if it is. Let's give it a gentle massage to get that braid out of the way a bit. See, if you bought a proper plug from a reputable manufacturer, generally they'll give you a cutting chart and show you how many millimeters of bits to cut off. With this, we're sort of winging it. Get what you pay for. I'm thinking that may not be how it works after all. Maybe we just push that up the inside. There, yeah, I think that's probably how it works. So we're going to need to get that length about right and solder our pin on. I don't think that length's too far out actually, so I'm just going to cut the braid off. There we go. Where's my sleeve gone? Did that exit off the bench? Oh, no, there it is. So that's more like it. Got half a chance now. Then this brass sort of knurled section there should push up on the inside and we'll get it all together. So next thing to do, I think, is just to strip a bit of the centre back. This is a polythene centre by the look of it. We'll work out how much sort of length we need. So that's going to end up about there. That's going to want to end up about there, I reckon. So not much left showing, to be honest. Let's just see if we can assemble it and see how it looks. That's not working at all, is it? I wonder if we do have to take a bit off there. Just going to straighten this centerpiece out so we can try and get it through the hole in the center of the plug, and then we can work out whether we've got the right depth, and then we can solder the center pin on. Yeah, that's looking something like. So I'm thinking we're going to want to cut that and leave that exposed there. Soldering iron is warm. Oh no, where's the pin gone? Have I just swept it off the bench? Probably. Good job we've got a bag of the things. We're going to need the old blue tack. Slip our pin over the centre conductor. Blimey, that is a good fit. And solder it up. That's it, that's all you need. Okay, let's see how far off we are. pretty pleased with that. Let's try and get that in on the camera, but yeah, that's pretty good. Right, pull the sleeve down. And let's see if we've got a crimp tool that's going to be our friend. Right. I think we probably have. I think it's probably going to be that one. But I just do want to do... just going to crimp it up on the lead like that. There's a little tip. You can use that to just push that sleeve down over the top and get a decent decent method of pushing it all together. So let's get that crimped on. Oh. Yeah, pretty happy with that. We've got some strands hanging out, but that's nothing to worry about. And yeah, the end is just about in the right place, so that's great news. So we can fit that into our 868 antenna there and our Paradar, and fit the box, make some measurements, cut this, bring this back in here, blah blah blah, fit more of these, job sorted. Let's get on with it. Right, well, I've been and made a coax cable there. It's about that long, and because I thought, well, they're both going to be the same length, I've actually got two that are the same length. They're going to be about right, so it's good enough for me. So I have got my quarter wave ground plane antenna and its little radome there. So yeah, let's fit that on. I'm going to use red for LoRa, I think, and green, red for TinyGS and green for no, I'm not. I'm going to use green for TinyGS. I knew I was getting there. Just thread that up through there, spin the antenna on. A gentle tweak with a spanner. Lovely. And it should sit nicely in there. With this little radome on the top. I'm just going to put a bit of tape around that when I'm done, just to centre it up. Yeah, that should be okay. So that's going to form a drip loop there, back round to the box. There, next trick, I'm going to go and fit the LoRa antenna to the other end. Right, well, the sharp-eyed amongst you may have noticed it's the following day. Just ran out of time yesterday, and I also found there was a problem with this mount, which is going to hold our Paradar antenna up there. So yeah, didn't sort of happen. I had to 3D print that last night. By the way, I've sealed the end of the connectors on the Paradar, because obviously we need an adapter from N down to SMA. I've sealed that with some of our favourite liquid insulation tape. That stuff really is good. That's not going anywhere. So yeah, right. I need to drill a hole in that, fit the antenna, wire it up, and get it configured. Let's get on with it. Right, I'm just going to put the cable on this to start with, just to make it easier. So I'm just going to use a dab of electrical insulation tape on there, just to seal up the connector. If I can get the lid off the can. Oh. Yeah, clearly some brute force required. Trick is to just get a dab on the outer threads, and then when you wind the connector on, it sort of seals it round, and we can finish the job afterwards. That's good. And seal that up good with our liquid rubber. Not pretty, but effective. Right. Right, the other antenna that was going to go on here is the ADSB antenna. Now, that is actually going to fit in the top of the mast with a little adapter I've made. So I'm not going to do that until this mast is at least in the bracket, because I need to be able to get at the end of the mast that's currently resting on the floor to feed the coax up the middle. So I think the next thing to do is actually connect the battery to the Meshtastic node, power that up and configure it so it can get on the network, and we'll go from there. But first things first, I'm just going to tidy those coaxes up a bit, I think. Right, soldering iron, solder the battery up. Right, so that's all configured and running. For those of you interested as to why I've got a moist brow, it's 33 degrees according to the environmental sensor, and it's not exactly in the sun. But yeah, there we go. So quite warm out here. Don't know what that is in American freedom units. You'll have to work it out yourself. But that's it. So next thing to do, I think, is to get it on the mast and fit our ADSB antenna. Right. Tell you what, certainly got a bit more weight to it now. Right, this is our 75 ohm satellite TV coax. I'm going to put that up the mast just until that comes out the top. And then we just need to feed it through this adapter into the top of the mast. Connect the ADSB antenna. It's just going to sit there like that. I think I might need to glue that, but I'll come back and do that in a minute. Right, well, I've just connected our 5-volt supply up onto these two Wago connectors from the workshop. It's not switched on downstairs yet, but I will just go and try that, and then I think we're ready to put the lid on. Well, 5 volts is on. I've got both TinyGS and Laura now powered up. Laura has been powered by the battery anyway, but TinyGS is now running. Looks like we've got a bit of a squished seal here. I'm just going to put that right. There we go. Right, let's just raise it into position. It was a bit hot for doing that sort of work today, and of course the Americans will let you know that any antennas put up in fine weather won't work a damn. But there we go, I've put it all up. I'm happy to report that it's all working perfectly. Here's our Meshtastic node, and yep, the reception seems about the same as it used to be. We're picking up as far away as the Forest of Dean, so that's good. The one massive improvement is flight aware. My node there for ADSB, we're getting lots of tracks. Look at that, almost 100 nautical miles away. Previously I was lucky to get 50, really. I'll look how the stats go in the next few days, but yeah, we've got a few aircraft showing on there, so that's a bit of fun. And the 868 TinyGS node has yet to receive a packet, but then again, it's only been up for about 40 minutes, so yeah, there are no satellites with 868 on board coming anywhere near us for a little while, so I'll see how that performs over the next few days. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish. There's a link below if you want to buy me a coffee, or it'd be very nice to see you on the Discord server. So if you want to do that, links there for you. But yeah, I'll see you next week. Cheers now. Bye.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust. They play nostalgic tunes, solder smoke, and the faint aroma of time in each repair. An art that's so prime. Fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit close, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. In Darcy's shop, with a touch of love, your picture's clear and true. It does as hands, pixels flicker, back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise at an angle. He bends the light through the lens, creating onyx nights. Oscillators creating sonic waves, bringing back the charm of retro days. Capacitors and resistors. In Darcy's touch, there's no misfire. Transistors dance to the rhythm of repair. Through the glow, feels like magic fills the air. Voltage pulses, the tune's melodic run. A symphony of sparks, where the work is never done. In Darcy's shop. With steady hands.
Well, that took some effort. It's just too hot for doing that sort of thing today, but oh, for God's sake, do it again. Forgot to minimize obs. Did that exit off the bench? Fuck's sake. For goodness sakes.